But then when you go and you say that you want the particular one at 3, then that turns into m, and it becomes 2 times 3, which is 6, so slope is 6. So generic notation is f prime. When you plug in into f prime particular value, in this case 3, you get notation m for a slope is equal to 6. So now you have x value is 3, m is 6, we need y. We find y when we plug 3 in the f of x, which is 3 squared is 9. So now for y equal mx plus b, I have y as 9, m as 6, x as 3, plus b, and clearly b is negative 9. So what is the equation? It's y equals 6x minus 9 in this particular case. So that was an example. Now, observe that from here to here, let me just use different colors so it's easier to see. Observe that from here to the derivative, we took the derivative. What kind you can encounter there? Product rule, quotient rule, chain rule, implicit. It can be anything under the sun. Trigonometric, inverse trig, right? So tangent line is the procedure. You are not learning that example to example because tangent line shows up in every section. It is the most important problem of chapter 3. So f of x could be product rule, chain rule, quotient rule, could not be function. It might just be a line of some sort where you have to use implicit differentiation. So make sure that you are using appropriate derivative, and the tangent line procedure will be the same. So you need x, y, and m in order to find the line. You will always find them if you sort through, if you solve, for a derivative, right, by plugging in x value. Any other questions or concerns during the tangent, for the tangent line? Now I remember, I believe so. Let me check, is the stream going now? Yes, it's going, yay. Okay, that was a second attempt at the stream. So I believe in implicit differentiation I gave this example that you really need to be careful. I'm not careful. Oh, here. Remember how I said find a tangent line? This was for problem 12. And you had this implicit function tangent xy, right? So you take the derivative of it. We are using the chain rule and the product rule embedded. So yeah, not easy. But observe the procedure to find tangent line. I never spent time looking for dy dx equals everything else like we usually do, because we don't care about that. It's much easier if we plug all of the values in. As soon as you plug in 0, 0 for your x and a y, which is the point at which you are looking for the tangent line in this case, you will replace every dy dx with m, and you will grind through calculation to quickly come up with a value for m. And you have your m, you have your x and your y, and you can go and find v easily. So you can do that all the time. You don't actually have to simplify algebra, especially if you have issues in that department. You should obviously practice and learn that. But to maximize your grade, as soon as you're done with the derivative, replace x's with x's, y's with y's, and all dy dx's with m's, and just grind through to find them the easiest possible way. I believe I gave another example of this. Yeah, I did. Here it is. So this is the entire problem with implicit differentiation solved. You have x cubed plus y cubed equals to 2xy and the point 1, 1. And I also give you the picture of how that actually looks like. So you see it's not a function, right? And at 1, 1, it has this red line is the tangent line. So we take the derivative, and see, I never solved for dy dx. I plugged in all x's and y's and replaced all dy dx's with m, and immediately came up with m is -1, and then grind through the rest of the problem. So it's fairly quick if you do it that way, and it's the safest, right? Because you don't shuffle algebra around, so less opportunities for mistakes. So tangent line problems can have vanilla derivative, right, the basic, or they can have product rule, quotient rule, implicit, chain rule, any of that stuff. Cool. So that's talking about tangent lines. The second part that I want to talk about are word problems and related rates. Related rates are the only money-making section in this chapter. Everything else is the stuff that technically computers can do for you. You will never take, I mean, we all have to face the reality of today. None of you will ever take derivative by hand, no matter what your job is, unless you end up doing what I'm doing, right, to teach others, right? They say, why do you need to learn algebra? So you can teach it to your kids, right? That's how it goes. So you will always be using machines to take derivative. So 10 sections from this chapter 3 will be replaced by a software. One section is what you guys have to do, and that is actually your job as engineer. So to take the physical reality problem, talk about it, and make mathematical models, and you look at those mathematical models, solve them, and they give you functions or results so you can build stuff. And we are talking about building buildings and airplanes and bridges and iPhones and other stuff, right? So we start with very simple problems, and then we evolve right into more complicated stuff. Now, this is the section where you had all of those formulas for volume and perimeter and area and Pythagorean theorem and trig setup and all of that stuff. So, you know, again, the more problems you do, the better off you are. What I want to talk about here is, one more time, change of volume in time is dV dt. So there is a way for you to detect that dV dt is the variable we're talking about. Change of volume in time, or with respect to time, either one. But also, if the units are given to you, you also know that that triggers that response. So if they say 35 feet cubed per hour, that also triggers dV dt, because feet cubed is a unit for volume, and hour is a unit for time. So when you read the problems, one or other or both are given, and you will always be able to decipher which one is which, where they go. So now, if I say the height of soda in soda can is decreasing at the rate of 0.7 inches per second. Right? At what rate is the volume changing? I just made up this problem. Now you know that the soda can has the radius of what? 2 inches?
No, not really.
Inch and a half?
Yeah.
All right. So radius of the soda can is inch and a half, and let's say the height of the liquid in the soda can is maybe 5 inches at the moment, right? It could be 3 inches, could be anywhere, right? Depending on how much it's gone. So, you know, thinking about the soda can, you know that it's a non-spiky, as we said in the class. It's a non-spiky object, so it's just area of the base times the height. But it's more important, you know, you can't start there. I understand that you know how this thing looks like, but I can also ask other things about this. So you go first and you say, okay, the height of soda is decreasing. If height is decreasing, I'm thinking out loud. This is how my head works. So if the height is decreasing, that means that the height is changing. The change in mathematics is captured with the derivative. The change has to happen in time. Happens with time, right? Time passes. So the information that they give me is this one. And since I am losing stuff, it's going to be a negative number. So this is, all of this is in my head. The height of the soda is decreasing. So since it's decreasing, it's changing. The way to write change in calculus is the derivative. So change in height in time. And because it's decreasing, I'm going to put negative 0.7. And I will say inches per second. Now, these units are just going to confirm what I wrote, because height is measured in inches, not inches squared or inches cubed, it's inches, and then time is measured in seconds in this case. Cool. At what rate is the volume changing? So now I want to know the change in volume. Now the units that we get here better be inches cubed per second, because those are the units that are given to us as the HDT. Now, those units, the answer is going to be a point on the exam. So make sure you have right units. Now, we know that we are talking about a cylinder. That's the soda can. And we know it's not a spiky object, which means that the volume for it is what? Area of the base times the height, which is, what's the area for the circle? Nope, that's the circumference. Pi r squared times h. Awesome. So to find related rates between h and v, I have to take the derivative of this formula in respect to time and get dv dt is equal to, now, on the other side, how many variables do I have? 1 or 2?
2.
Or
One.
I can make the
One.
question even worse, or 3, if I put pi, we know.
One.
I have 1. Very good.
Oh, yeah, you can plug in the radius.
Yes. See, radius of the can is constant. Cone is the evil one, because radius changes as the height changes. But over here, as the height changes, your radius is constant, right? So we can actually plug in 1.5 there. 1.5 squared is going to be 2.25. So we can actually plug that in. But the only variable in this case is h, and whose derivative is 1. So we actually have pi r squared dh dt. So dv dt is going to be pi times 2.25 times negative 0.7. And look, you are getting a negative number, which makes sense, right? Because if the height is decreasing of whatever is inside, that means that the volume is decreasing, right? So now you punch all of these numbers in the calculator to decimal precision, like 3.14 times 2.5 times 0.7, and we get
negative 1.75 pi.
You should have multiplied by 3.14.
Hey, you can't use an equal sign.
Yeah.
Then a negative 4.9.
Inches cubed per second. This is all applied, so in engineering you multiply by a safety factor of 1.5, as long as it's 50%.
When we're taking tests, will you tell us what we want, like, will tell us what decimal place you're onto, or do you want to just automatically assume?
Well, if it's money, you know it's 2 decimal points. In general, you know, 2 decimal points is fine. Okay. There you go. You can leave the answer in terms of pi. That's okay. But because we had 0.7 and then 225, it's not like if I had pi times 6 times negative 2, I would leave that as negative 12 pi. Because that's beautiful, right? But then when you already have an ugly decimal, multiplying pi, well, then just go all out. You know what I mean? Can't have it to be partially beautiful and partially ugly. That doesn't kind of. Actually, it does. Like when you see a pug, yeah, a pug, right?
No, Pug's not just beautiful. I was thinking about it. No. I've never understood that. Pugs are
Yeah,
just
it's like when when it's just like things that only mother can love. You know what I mean?
No. They're all my babies.
As soon as they're born, they get a strike to the face.
Oh, is that what happened to you? Oh shit.
Oh, this one is getting worse now. We should actually end it quickly.
Stream. No. My friends got like pedigree bulldogs and said they can't like read on their own at all.
No, they can't.
Like,
They're
Yeah.
horrible
Yeah.
biological travesties, but we
And they
need
can
to
hardly
love them.
breathe.
Yes, we need to love them.
Okay.
Like, that's what I'm doing after college. I'm just buying a farm, getting like nothing but pugs and bulldogs, and just live out my day.
You gonna run a farm?
No, not breeding them because they should like not breed, but like just live on a farm.
Yeah, but what are you
Nothing
gonna,
but bulldogs.
We're not there.
what
I
are you
have
gonna,
one at home, you can take it.
what are you gonna do for food?
Have them hunt for me.
Oh, pugs. Okay, I see.
No, I didn't want that to be implied.
Well, it was.
No, like
Progressive thinker. Yeah, all right.
they'll hunt me rabbits, and I'll just eat like the rabbit
Never gonna
population.
catch a rabbit.
That's words.
I'll catch rabbits. Yeah.
You would never
Do you
catch
realize
rabbits.
I've had duck before. Very good.
That gets
I asked about rabbit.
I've never had rabbit.
apparently rabbit tastes like duck. So
You're a duck?
Yeah.
Of course.
Delicious.
This is how I. It's human or it's edible?
yeah,
I want to look at it.
Have you ever had a dog?
I would eat a
Probably. I ate at McDonald's twice in my life. Once in
Yeah, see?
White Castle and once in Burger King.
Oh
So
my god,
probably,
White
yeah.
Castle, I'm sorry.
I don't know.
I used to
Never again. At White Castle? In Heber?
Yeah.
You know, what's
I know one of them was
Huh?
working
Did he
with
work
horse
there?
meat, so I'm not sure which one of them. I think
About a
Burger
year
King,
ago?
maybe. I don't
You
know.
I
know?
quit a year ago.
I'm
you remember, like,
definitely
Diane
partial because I had
Crystal?
horse meat.
Diane.
Yeah.
Dog meat?
You were still active on that?
Like when
Yeah, you know?
Yeah, I know.
We're gonna have a conversation later.
Alligator. I got alligator.
Because that's my friend's thing.
I ate the Friday.
I gotta go.
What
kind of guys?
Florida.
I don't believe
Oh,
you.
my
Yeah,
God.
that's right. I had Florida.
No, I didn't order it. It's just I had a burger, so you never know what you get.
Sure.
Yeah. Maybe like once in my life.
Right? Whatever. You're vegetarian, so it's
No,
Are you not?
I'm bored.
What?
No, I'm not. That's
What should we do?
Why?
like a lot of people.
I mean, like, once you eat people, of course,
A lot of people are.
It's actually not healthy for you.
It's not good for the environment either. If you look at the cost effectiveness of the calories from meat versus the calories from plants, it takes a lot more to make the same amount of calories in vegetables.
That's how you preach it right there.
Well, you have to get a lot of plants to raise a big cow.
Yeah. It's just like cheap grass.
Because you feed them the dead body parts of the other cow. Haven't you ever seen, like, any of these documentaries?
No,
Like, we made this efficient, okay?
there's like macrobiology at play though.
This is where we start talking about cannibalism. All right.
No, it's not. I mean, yeah, I guess it is, but, like, not us.
Is it just the desert island situation again, or?
No, I didn't. That's crazy.
All right. This so this review is now turning into a biology review.
Yes, and I will teach it.
Is there any concept or question that you would like me to answer for the upcoming exam, other than what's on the exam? Because I already did that.
What's the answer to the extra credit?
Well,
I don't even. There's no extra credit on that.
42.
No extra credit. It might be
A replacement
replacement
problem.
yeah.
Replacement problem, but no extra credit. You have those quizzes if you want to do them.
Yes.
Oh, that's
That's how I learned the material.
That's really all you gotta do. If you fill those out, you're pretty comfortable. Decent test.
yeah. What are you gonna do?
Questions, concerns, anything? I'm just questions.
No, we'll call you. We'll call you.
Sit there for like hours. You ever seen that Tosh Point special where it's like, what if the races taste like what they eat? It gets a little out of hand.
Wait, what if racist or wait, what?
All right. So if you have any questions, just
like,
bring them forth, and we'll work. Lab time.